In panel data regression, we have two kinds of fixed effect. One is the entity fixed effect, which is constant over time but differs across entities. And the second one is time fixed effect, which is constant among entities but differs among time periods. We'll look into the entity fixed effect first. So, regressions with entity fixed effects, it allows us to control for variables which do not vary across time but varies across entities. And this model has n different intercepts, each for each entity, which means that if you have a model with a y hat 1 and a y hat 2, then the slope is the same, the beta 1 is the same, but the intercept differs. Okay, so this is y and this is x. And these changes in intercept can be represented by binary variables, one for each entity. And these binary variables absorb all the influence which is constant among entities, but which differs among entities but is constant over time. So, if we have this regression model, then we have the fatality rate, and this is explained by an intercept, a population intercept, plus the effect of bear taxes, a change of $1 in bear tax on fatality rate, plus the effect of culture, 1 unit of culture change on fatality rate. So what we would like to see is, because we want the causal effect of a change in bear tax on the fatality rate, we would like to estimate the beta 1 as closely as possible, controlling for other variables. So here we would like to control for culture, and culture might be thought of the attitude in the community towards drinking and driving. And we did not include culture in our first regression, and because of that we might have omitted variable bias. And why is that? Well, we do have the two conditions for omitted variable bias. The first one is that the omitted variable is correlated with your x variable, and the second one is that the omitted variable actually explains something of the y variable. So in this case, we have the cultural attitude, and we believe that this is correlated with the beer tax, because some states in the US are more religious than others, and these states might want higher beer tax. And the second one is that the cultural attitude is probably correlated with the fatality rates. So the acceptance of drinking a bit and then driving might differ across maybe rural and not so rural states. Okay, two concepts or aspects. The cultural attitude is not something you can observe. So we would not be able to gather data on this variable. And this causes us to not have the variable in our model, and we can't control for this cultural bias or culture in our model. So we can't have culture as a controlling variable. And the second one is that we assume that culture is constant over time, because culture is not something which changes rapidly, and which means that if we include something in our model, a measure of culture, then we can assume that it's constant over time, which means that it only affects our intercept and only shifts our regression line up or down. So this means that we have n different intercepts, one for each entity, and we can actually write the intercept for each entity as the population intercept plus a kind of measure on the difference between the population intercept and the state intercept, which is just sum to alpha I. Okay, so these alphas, these intercepts, is one intercept per entity. Okay, so each entity has its own intercept, which gives you this fatality rate and beer tax here, and you would probably expect this to be downward sloping, and this would be for I equals 1. So this is the fitted fatality rate, and you can make one of these regressions, these fitted regression lines, one per entity. So the only difference is the alphas. So this is alpha 2, and this is alpha 1. So this is really the point behind the entity fixed effect, that you allow for the different entities to have a different fitted regression line based on the change in intercept. And what's constant here, constant over all entities, is the slope, right? The beta hat on the beer tax. So here you assume that there is a fixed effect which is different from each state, from each state, and from one state to another, but the slope on the beer tax is the same for all the states. Okay, so this equation is actually called a fixed effects regression model, and the parameters alpha, they are kind of treated like unknowns. So they are treated like separate variables, one variable for each state. And sorry, these intercepts, they can be thought of as the effect of being in state 1, 2, or 3, and so on. and they do not change over time. Okay, so they do not have the subscript t, because we are going to look at time-fixed effects later, where you have to have the subscript t, where the effect changes over time. But here we estimate a fixed effect which changes over the entity but not over time. So, and this panel data actually allows us to control for all these variables which differ from state to state but are constant over time. And that might be quite many unobservable variables.